Salam and welcome. So today we're going to be working on the question on the screen that says, in a certain ideal heat engine, 10.00 kilojoule of heat is withdrawn from the hot source at 273 kelvins and 3.00 kilojoule of work is generated. What is the temperature of the cold sink? The first thing you have to know is this. Let me write out the solution. Is for you to know that you have to write out the parameters. You have you have the heat of the hot sauce to be 10.00 kilojoule. You're told that the heat is withdrawn from the hot sauce at 273 kelvins. So I'm going to put a negative here because we're talking about the heat of the hot sauce. The hot sauce now has less of 10, sorry, negative 10.00 kilojoule because the hot sauce has a temperature, it has a particular amount of heat, and part of the heat is withdrawn, meaning it's taken away. So in order for you to know the current value for heat of the hot sauce is going to be negative 10.00 kilojoule. And they said that happened from the first from the hot sauce at 273 Kelvin. So the temperature of the hot sauce is going to be 273 Kelvin. And then we're told that 3.00 kilojoule of work is generated. Okay, so work is 3.00 kilojoule. And the temperature, and we're asked now to find the temperature of the cold sink. So the temperature of the cold sink is what? Now we've been given the heat of the hot sauce, the temperature of the hot sauce, the work done, and we're asked to find the temperature of the temperature of the cold sink. Now, before we do anything, it's important for you to know that this is the formula we're supposed to use. The heat of the hot sauce divided by the temperature of the hot sauce plus the heat of the cold sink divided by the temperature of the cold sink equals to 0. So rewriting this formula, we can have it as the heat of the hot sauce divided by the temperature of the hot sauce equal to negative the heat of the cold sink divided by the temperature of the cold sink. So this is basically yeah, this is it. This is 100% it. Now I wanted to mention something. We've been given the heat of the hot sauce. We know that. We know the temperature of the hot sauce. We don't know the heat of the cold sink, but we don't also know the temperature of the cold sink, and we're supposed to solve for it. Now, in order for you to be able to know what's going on here, you have to understand how an ideal heat engine works. In the ideal heat engine, the temperature would is gotten from the hot sauce, is withdrawn from the hot sauce. Sorry, not the temperature, the heat is gotten from the hot sauce. Hence, the reason why it's withdrawn, why we have a negative 10.0, and part of that heat is used to generate work, meaning work is done using that heat within the engine. Now, whatever is left of the heat that is not used to generate work is going to be deposited into the cold sink. So the heat of the cold sink is whatever is left over after work is done. So that would simply be the heat. Let me write it up top here. That means that the heat, okay, of the cold sink would be QC is just going to be whatever the heat of the hot sauce is, whatever we used minus the work done. So that's actually going to be 10, okay, 10.00 kilojoule minus 3.00 kilojoule. And you may be wondering, well, we use negative. Why are we not using negative? Don't forget, we only attributed negative for us to know that we're taking from the hot sauce. Like we're taking all of it, all of it energy. But that does not mean the heat itself is negative. It's just negative at the hot sauce. So that's the reason why we can just say 10 minus 3. And we know that the heat of the cold sauce is going to be 7.00 kilojoules. So let me just write that up top. So heat of the cold sauce, heat at the cold sink is going to be 7.00 kilojoule. Again, don't forget the negative that we're using for the hot sauce. The heat there is just to tell us that it was taken. It's just to denote the fact that it was taken from the hot sauce. It's not necessary that the value in of itself is negative. So that's one thing. Or if you want to put negative there, I don't know how that would work, but you would have to put like an absolute in between the negative 10.00. You have to put an absolute there. But anyways, 10 minus 3 is 7. So now we have all of the information we need. We just have to simply substitute. So we have 10.00 kilojoule. So we're substituting into this formula, into this equation right here, 10.00 kilojoule, okay, divided by the temperature of the hot sauce. So that would be 273 Kelvin equals negative the QC, which is 7.00 kilojoule, okay, divided by TC, the temperature of the cold sink. So of course, cancel out this. So you cross multiply. So you have 10.00 kilojoule TC is equal to 7.00 kilojoule times 273 kelvins. So divide this by 10.00, divide this by 10.00 kilojoule. Of course, kilojoule. Of course, you cancel out the kilojoule, cancel out the kilojoule, cancel out the kilojoule here, cancel out the kilojoule. So that would be cancel out the 10 as well, because we're trying to find just TC. So TC is just going to simply be 7.00 times 273 Kelvin divided by 10.00. So that would give us the temperature of the coating to be 191.1 kelvins. And of course, since we are basically since we are working with a question where the lowest number of sig figs is 3 sig figs, we can basically write this in 3 sig figs. So the temperature, okay, of the cold sink is actually 191 kelvins. And this is just basically the answer to the question. If you have any questions, please put it in the comment section. If you have suggestions, concerns, put it in the comment section. If you're a student who is struggling with any of your STEM related courses, I am a tutor and mentor for students who are trying to succeed and excel in all your STEM related courses, whether you're in middle school, high school, or college. If you'd like to see the services that I render, or if you'd like to book an appointment, make sure you email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.